Hello everyone and welcome to this video where I will take you through IMM Photonics' VCSELs. In the next 15 minutes, I'll show you how our VCSEL technology moves from components to complete solutions and why that matters for applications in industries like sensing, metrology, medical, and more. So let's dive in and talk about a tiny light source that has been quietly transforming the entire photonics landscape. Before we dive into the tech, here's who we are and why our work in photonics matters. Founded in 1992, headquartered near Munich, with a production site in Bavaria, we specialize in customer-specific photonics, including laser diode modules, fiber optic test devices, UV LED systems, and VCSELs, of course, serving a diverse industrial market, including sensors, medical devices, and fiber testing infrastructure. In short, customization is our DNA. Now, what really sets IMM Photonics apart? Three words: optics, mechanics, and electronics. And we own all three. From custom electronics and laser safety, to precision mechanics, to tailored optics, and patented fiber coupling concepts, we are built for integration and scale, including robotic assisted production. And that's how we deliver reliable modules and not just emitters. Here's the thing: you don't come to us for a diode, you come to us for an outcome. And how do we deliver that? We integrate optics, electronics, and thermal management and packaging so you can go from chip to system faster, whether it be sensing, LiDAR, medical imaging, or telecom. It's built for reliability and customization at scale. Now let's zoom in onto the core of our VCSEL lineup: compact, efficient, and ready for integration. Our portfolio spans the 850 nanometer variants, one at 1 milliwatt and 1.5 milliwatt, and the 760 nanometer at 0.5 milliwatt, covering mainstream sensing and dedicated oxygen lines. But these aren't just VCSELs. They are engineered building blocks for precision photonics: polarization locked emission, anti-reflected coated window, hermetic packaging, circular Gaussian beam, single mode operation, an integrated photodiode, high side mode suppression ratio, and polarization extinction ratio just are some of the basic features that our VCSELs offer, and hence they are optimized for real-world integration. Now, stability is everything in photonics, and this is where our VCSELs really flex. Our 850 nanometer devices, for example, show a wavelength shift of about 0.053 nanometer per Kelvin, outperforming typical literature values. And this is a feature that is crucial for applications like interferometry and spectroscopy, where drift kills the accuracy. A clean beam means a clean signal, and our VCSELs just deliver exactly that. With an ellipticity of more than 0.87 and a beam angle of about 14 to 15 degrees, you get near circular beams that align easily, couple efficiently, and keep your downstream optics simple. Now, if you're wondering where our VCSELs stand out, here are some of the performance metrics that matter in the real world applications. For example, the side mode suppression ratio. It's 10 dB on the 1 milliwatt variant and between 17 and 20 dB on the 1.5 milliwatt variant. And this ensures clean single mode operation. For example, the polarization. The 1.5 milliwatt and the 1 milliwatt, they both show zero flips during operation, and they have a polarization accuracy of plus minus 15 degrees, which makes it very good for alignment purposes. Moving on to the slope efficiency, up to 0.75 milliwatt per milliampere. This means these are great for low power systems: cleaner signals, higher precision, and less energy. Gas sensing demands precision, and our 760 nanometer VCSEL is built exactly for that. For TDLAS and respiratory monitoring, at 25 to 30 dB SMSR, 0.5 milliwatt output, a 0.05 nanometer per centigrade tuning capability, and 11 degrees circular divergence, it is compact, sensitive, and integration friendly. Now this is where the magic happens, turning a VCSEL into a complete optical module. So we deliver VCSEL plus a collimator for narrow beams, or maybe a VCSEL with diffraction optical elements for structured light, or VCSEL plus fiber pigtail for telecom and medical applications, and full modules with integrated drivers and thermoelectric coolers, reducing complexity and time to market. Let's look ahead and what the outlook is for our VCSEL portfolio at IMM Photonics, because the next evolution of our VCSELs is all about control. Temperature is everything in photonics. So by integrating a thermoelectric cooler and a thermistor right into the module, we locked wavelength precisely, stabilize the performance in harsh conditions, and extend lifetime through active thermal regulations. We are targeting Q1 of this year with prototypes for short-range LiDAR, medical and biosensing, and high-speed data links, bringing lab-grade stability into compact modules that you can deploy. And long term, looking further ahead, we are moving towards a fully integrated photonic platform. Yes, we are developing micro optics directly on the VCSEL chip, micro lenses, diffractional optical elements, and beam shapers, plus polarization mode fiber coupling for telecom and quantum systems. Expect the first prototypes with integrated optics in the second half of 2026 and a path toward fully integrated VCSEL with optics, electronics platforms, and beyond in 2027. Plug-and-play modules with lower alignment cost and extremely high precision. So what can you actually do with a VCSEL, or more concrete, with IMM Photonics VCSEL modules? So here are a few examples and the fields where they're already reshaping the game. So this slide maps three powerful directions: quantum communication, AR/VR with self-mixing interferometry, and non-invasive health monitoring. Think of quantum as security encoded in physics, not just math. Polarization stable VCSELs and also in combination with polarization maintaining fiber coupling make compact, repeatable, secure sources. Now think of AR/VR with self-mixing interferometry as turning cavity feedback into super precise motion data, enabling low power embedded tracking. Think of non-invasive sensing as photonics becoming personal. Wavelength-specific illumination and gentle thermal modulation transforms the tissue into a biosensor. And over the next minutes, I'll unpack each application, show what our devices enable, and where the lab value lands for real products. Quantum communication. Let's start with one of the most exciting ones. With a polarization stable VCSEL, what we do is we encode quantum keys, or we can encode quantum keys as orthogonal polarization states and transmit them through PM fibers using protocols like decoy state BB84. Now what's the big deal in this? First, VCSELs bring stability and compactness. You can integrate them into a small, rugged transmitter instead of relying on bulky lab lasers. Second, they are energy efficient, enabling scalable systems. And third, they are manufacturable in multiple formats, different TO-CAN packaging, and as well as fiber coupled that engineers already know how to deploy. So what's the takeaway? Physics level security enabled by compact sources that are practical outside the lab. That's how we move from demos to field ready QKDs. Next, the secret ingredient behind ultra precise AR/VR tracking, self-mixing interferometry, or commonly known as SMI. So in SMI, a fraction of the reflected light re-enters the VCSEL cavity, modulating its internal state. We read that modulation to extract micron level displacement with excellent signal to noise ratio. So by pairing the VCSEL with beam shaping optics, diffractive elements or microlenses, we can tame speckle, shape patterns, and reduce alignment sensitivity. The result? A compact, low power embedded tracker for AR/VR headsets and controllers. For OEMs, this means fewer external sensors, lower power budgets, and a tighter industrial design, all while improving precision. Now that's the kind of system level win that moves products forward. And here's where photonics gets real personal. Continuous health monitoring without needles. completely non-invasive. By choosing application-specific wavelengths and applying gentle thermal modulation, VCSELs can detect changes in tissue optics linked to blood oxygenation, glucose, and other parameters. Now, why VCSELs again here? They are stable, they have very narrow emission that helps isolate spectral features. They are compact, low-power modules, they fit wearables, and of course, the integration options. Collimators, fibers, drivers, thermoelectric coolers, and this can tune performance for comfort and signal quality. Now the vision here is continuous, painless monitoring that shifts care from episodes to always on-site insights, a powerful step for patient comfort and preventive medicine. Finally, if you're innovating with light, here's why IMM Photonics should be on your shortlist. We combine VCSELs plus optics plus mechanics and electronics into ready-to-integrate modules. We move beyond the datasheet to solve system-level problems, accelerating your time to market. Bring us your challenge, we'll co-create the right module and provide samples, engineering support, and a roadmap that scales with you. Thanks for watching. Let's build the future of photonics together. For more, visit immphotonics.de. Check out our latest VCSEL website and the latest application note. We at IMM Photonics are looking forward to hearing about your application and how we can help make it real. Thank you, everyone.